In this video, we are going to be looking at how to solve absolute value equations. So in order to do that, it would be helpful if we had a good definition of absolute value. Absolute value actually means the distance away from zero. It's a measurement. So therefore, the answer to an absolute value question is always going to be positive. So look at this one. I have some number, and the absolute value of that number is 7. That means that this number is 7 units away from 0. So I have two choices. That number might be 7. 7 to the right is 7 units away from 0. That number might be negative 7. 7 to the left is also 7 units away from 0. So if we have the absolute value of 7, we get 7. And the absolute value of negative 7 also equals positive 7. Both of those turn out to have a positive answer. So look over here. We have some number whose absolute value is negative 4. That means that number, the measurement of the distance away from 0 is negative 4. Well, that's not possible. Distance as a measurement is positive. So in this case, we're going to have no solution. All right, let's look at the steps of how to solve absolute value equations. There's 4 steps, and we're always going to do these same 4 steps in this order. First, we're going to isolate the absolute value expression. That just means get the absolute value by itself. And then we looked at on the last screen how we could move to the left or to the right. So we're going to set the inside equal to a negative value, meaning we move to the left, and also set it equal to a positive value, meaning that we move to the right. Then we're going to solve the equations that we get and check for extraneous solutions. So extraneous solutions may not be a term you're familiar with. What are extraneous solutions? Well, they are solutions that make one of the cases true, either the positive one or the negative one, but they make the original equation false. And we always have to check for that. Pause the video and write that down. All right, we have 2 special cases for absolute value. The first one is if the absolute value is equal to a negative number. So we already looked at this. Absolute value by definition measures distance, which is positive. So after you get the absolute value by itself, after you do step 1, if the absolute value is equal to a negative number, you can say that there is no solution. All right, another case is if the absolute value is equal to 0. So again, by definition, absolute value measures distance away from 0. Well, there's only one number that is 0 units away from 0, and that is 0 itself. So in this case, we're only going to have one equation to solve because only 0 is 0 units away. When we take away the absolute value bars, we're not going to have both equations like we normally do. We're just going to have one. Okay, let's put this into practice. So turn to number 6 in your notes. Let's solve number 6 together. Step 1 is to isolate the absolute value. Well, you can see here the absolute value is not by itself. It's multiplied by 3. So to get it by itself, the first thing I'm going to need to do is divide both sides by 3. So I have the absolute value of m plus 8 is equal to 13. So I have the absolute value equal to a positive number. That's good. I've measured that distance. So I can say I might have gone 13 units to the left. I might have gone 13 units to the right. And I have to solve for both of those possibilities. So to get m by itself, I'm going to subtract 8 on both sides. I get m equals negative 21. That's one possibility. And I'll subtract 8 from both sides on this one. I get m equals 5. So you'll notice that I got a negative answer right here. That's okay. I'm not saying that it's an error if you get a negative number here. What I'm saying is if the absolute value is equal to a negative number, that's a problem. It doesn't mean that the things inside the absolute value cannot be negative. All right, step 4 was to check for extraneous solutions. So let's do that. So I'll go to my original equation and put negative 21 in place of m. So inside the absolute value there, negative 21 plus 8, that's going to be 13. Oh, negative 13. All right, absolute value measures distance away from 0, so the absolute value of negative 13 is positive 13. And 3 times 13 does equal 39. So the first one is good. That's a good solution. All right, let's check the second one. Let's substitute in 5. All right, inside the absolute value, 5 plus 8 is 13. And the absolute value of positive 13 is also equal to positive 13. It is 13 units away from 0. And just like before, 3 times 13 is 39. So that one is correct too. This one turns out to have 2 solutions. If you choose to do the delta math for this, you'll type in negative 21, comma, and then you'll type 5 in the second box that's going to open up. It's important to type in that comma, and that's how you're going to be able to type in your second solution. Okay, let's solve this one. So notice on this one, I've got 2 numbers on the outside, and you might be tempted just to do 9 minus 4 equals 5. But think about your order of operations. This 4 is multiplied, and do we do multiplication before or after subtraction? Well, multiplication comes first. So I can't subtract because I have not yet multiplied. So when I get the 9 and the 4 away from the absolute value in order to isolate it, I have to do it one at a time. So I'll subtract 9 first. That 9 is positive, so I'm going to subtract it to move it to the other side. All right, and now I'll divide both sides by negative 4, working to get the absolute value by itself. Step 1 is to isolate. And I see that my absolute value is equal to a positive number, so I can complete the problem. Up here, I had a negative number, but notice that the absolute value is not yet isolated. I can't say no solution until after I do step 1. All right, let's set 6 plus 10 equal to negative 6 because I could have moved 6 units to the left. And let's set 6 plus 10 equal to positive 6 because I could have moved 6 units to the right. All right, so I'll subtract 10. My first possible answer, C equals negative 16. Then I'll subtract 10 here. And my next possible answer, C equals negative 4. All right, let's check and see if either one of those is extraneous. So I'll put in the negative 16 first. All right, and again, I'm not going to subtract that 9 and 4. I'm going to do the order of operations. I'll do what's inside the absolute value bars first. Negative 16 plus 10 is negative 6. The absolute value of negative 6 is positive 6 because the measurement is 6. It's 6 units away from 0. Okay, and now I'll multiply before subtraction. 4 times 6 is 24. And 9 minus 24 does equal negative 15. So that one works out. That is a good answer. All right, let's check negative 4. So I'll do the same thing. I'll go back to the very beginning and put negative 4 in place of C. All right, order of operations, I'm going to work inside the absolute value bars. And the absolute value of positive 6 is positive 6 because it is 6 units away from 0 to the right. 4 times 6 is 24. And 9 minus 24, oops, miscopied that. Let's make that a 15. 9 minus 24 is negative 15. So that one is correct as well. Helps if you can read your own handwriting. So this one has 2 solutions, and again, you would type that into delta math with a comma. Okay, let's do this one. You'll notice immediately that this one is different because I have an N on both the left and the right. But we're still going to do those same 4 steps. Isolate the absolute value first. Five n plus 1n is 6n. All right, now let's do the left and the right. Let's do the negative and the positive, my two cases. So first, moving to the left, and be careful to distribute that -2, -1 to both the 6n and the 2. I have to do the negative of that whole side, so I have to remember to distribute. On this one, I'll do the positive one, so I'll just leave it alone. Okay, let's solve each of those. So on the left, I'm going to choose to add 6n. I want my variable to be positive. That's just a little bit easier to work with. And now I'll subtract 8 to move it away from the n. And divide both sides by 4, -10 over 4, which will simplify because 2 goes into both of those, -5 over 2. Okay, let's do the one on the right. So this time I'm going to choose to add 2n because that's what's going to give me a positive variable. Subtract 2 from both sides and divide both sides by 8. So I get 6 over 8 is equal to n, which I'm going to choose to simplify. 3/4 equals n. Okay, so let's check both of those. I need to check for my extraneous solutions. So I rewrote the problem over here, and that first one, -5/2, and I need to put -5/2 in place of each one of those n's. So all 3 n's had to be replaced by -5/2. Okay, to save time, because the video is going to run out, I'm going to choose to use my calculator and substitute this left-hand side into my calculator all at one time. If you cannot remember where the absolute value is, you can type the math button right here and then go over to NUM. Oops, there we go. Go over to NUM, and the very first thing you're going to see is ABS, which is the absolute value. So if you go there, that's what you'll do to type this in. So you can see that I typed it in already. There it is on my calculator. And on the left-hand side, I got 25.5. And on the right-hand side, I got -0.5. Well, 25 over 5 does not equal -0.5. So that means that this solution is extraneous. This solution made my special case true, but it did not make the original equation true. So that one's not going to work. All right, let's try 3/4. So again, I'm going to have to put 3/4 for all of my n's. And again, to save time because the video is getting ready to end, I went ahead and typed that in my calculator using the math and then going over to NUM and then choosing ABS for absolute value. And on the left-hand side, I got 2.75. On the right-hand side, I also got 2.75. So that one checks out. That one is a good solution. The real answer, the only answer to this question, n equals 3/4. Okay, you never know ahead of time if both of them are going to work, if only one of them is going to work, or if neither one is going to work. So anytime you have an absolute value equation, you want to try both of your solutions and make sure that they work. You can't say, well, this one works, so I know that one won't, or this one doesn't work, so I know the other one has to. You could have two solutions, you could have one solution, you could have no solution. So it's really important to always go back and check all of them.